So today we are going to be dealing with the Quiz 2 preview. Again, as I was mentioning before I started this, it's going to be a little bit shorter than the preview, the actual quiz, but the setup will be the same. Other reminder, which I didn't have before right now here, when we're into the factoring part here, which is going to be most of our first page, remember you have a help sheet available, and there are more available in front of the folders as well, bless you. If you need some assistance as you go along with these, and having a little assistance never hurts. So factor each completely. All right. I see 4 terms. Grouping. So we're going to pair these guys off. And like we did before, we're looking individually within each pair for what they have in common. So whatever that happens to be, maybe they don't have a number in common, but they do have a variable part. We're going to take the smaller degree, the smaller of my 2 exponents. And then it basically comes down to, okay, what would I times this by to get to here? Well, I see I don't have the 8. I need that. I got 2 n's. I need to get to 3. So I need 1 more. And then over here, I've got n squared, but I need it to be negative. So if I multiply n squared times negative 1, there'll always be 2 terms inside your parentheses. So even if this would have been plus n squared, I'd put plus 1. I got to put something there. So if you think back to when we were doing these, my goal now is going to be, when I switch and I'm looking at my second pair, the parentheses better be the same when I get done. Because if they're not, I did do something right. So I look at these 2 and I'm like, okay, both divisible by 4. If I needed to, I could use my multiplication chart. So I'm like, okay, is it going to be positive or negative? Well, let's see. 4 times what gets me to positive 32? 8. And I need the n. So far, so good. 4 times what gets me to negative 4? Negative 1. So it looks like that 4 is going to be positive. And before I give myself a pat on the back and say, woo, I'm going to the next one, remember, to get it into its final form of my answer, I'm going to take my greatest common factors. I'm going to put those together. I'm going to take my common factor, my 8n minus 1, and put them together, and off I go. So as we're going through these, and I'm going to do that again on the second one, but there will be some sections where there's lots of problems that I may skip a problem or 2 here if it kind of seems repetitive. But here I think this is a good place to stay since, you know, this is the factoring F word, the algebra 2 F word. So hitting it up a little more is not a bad idea. Okay, 21 and 35. Now again, I could play with the calculator if I wanted to, if I wasn't sure what went into both of those. Another option I would have, if my eyes can scan quickly, would be to look around and see, yes, where I might see a 21 and a 35 in the same column. If I follow up to the top, that'd be 7. What exponent am I going to want on my variable that I pull out? X squared, because that's the smallest one I see. So I get that rolling. 7 times what gets me to 21? I got 2 x's. I need to get to 3, so I need 1 more. And I just kind of keep working my way through that. 7 times what is 35? And I've already got my x squared. Switch them guys around. So here I get to this one. I'm like, okay, remember, biggest number that divides in, not just any number. Like here I might look and I'd say, ooh, 2 divides into both. That's true, but my parentheses won't be the same. So what's the biggest number that divides into 18 and 30? 6. 6 times 3 is 18. I'm feeling good. 6 times 5 is 30. I feel even better. Because now I take my common factors, I tuck them together. And I'm good. Okay? So if I see 4 terms, that's how we're going to roll with that. But again, I've got the blue sheet to help remind me of that. Okay? Other factoring. Now here I happen to look, and I'm like, okay, that looks kind of weird. So at first maybe I look, and I see that it's a 3, and I'm thinking, well, maybe it's like a sum or difference of cubes. But then I look, and I'm like, well, wait a minute. There's like more stuff going on here. Remember our golden rule. Do they all have something in common that I can take out first? They do. They all have an x. So if I take that out, it just reduces each of my terms by 1 degree. Okay, and I apologize. We have not been doing the solving stuff on these, so you can get rid of that equals 0 part. We're just doing the factoring. It doesn't say solve. That's on me. And so now what I have left in the parentheses, you're like, oh, that's just a diamond. So the x is still out here. I can't forget that. But now, I'm just doing my multiply and add thing. Okay, don't have to do slide and divide, nothing fancy. The even better part is there's only one way I can multiply to get 3. 3 and 1. And all the signs are positive. It doesn't get much better. So always look to see if there's that common factor. And it's going to be the same idea on 4. They both have an x. Okay. Which means these each reduce in degree by 1. But be careful, I'm not done. Because if I take a peek, I notice, hey, x squared. Ooh, is it a difference of squares? Ooh, yeah, because there's my 4. So maybe I jot down what I square to get each term. Maybe you don't need to. And I just follow the pattern on my sheet. First plus second. First minus second. And I'm set. But again, let the blue sheet guide you if need be. So I kind of keep playing. I'm like, okay, factor each completely. Now I'm seeing cubes. All right, so I look at first, I'm like, there's a plus in the middle, so maybe it's a sum of cubes. But I'm looking at 54 and 128, and I don't see them in the list. Oh, wait a minute. Does anything divide into 54 and 128? That becomes my next question. So, I start playing a little bit. Maybe I'll start playing with some small numbers, because I'm kind of keeping an eye on that list of cubes to see if something's going to show up that helps me as far as that goes. So maybe I look here and I go, okay, let's see. 54. Whoa, that wouldn't help me. 54 divided by 2. Okay, that's 27. Cubes is 27. Ooh, 27's on the list. All right. 128 divided by 2. 64. Is 64 on the list? Oh, 64 is on the list too. Okay. So if I pull out a 2, I'm going to have 27x cubed plus 64. So now at this point, again, I'm not on my own. I'm not alone on this. I've got my form right here. What I have to do is figure out what I cubed to get each part. And if you did what I'd mentioned before on your help sheet and jotted down the cubed roots of these, you'd be able to look and say, okay, so that would be 3x, and 64 is 4. And now I'm just going to copy my form. So I've got my 2. And what's the form say? Well, it's plus, so it's first plus second. 3x plus 4. Then I'm going to square my first term. Now remember, when I square the first term, it's everything that's there. I'm squaring the 3. I'm squaring the x. Switch the sign in the middle. Multiply my two terms together. 3x times 4 is 12x. And square my last term. 4 squared is 16. Straight up follow the pattern that you have. And it would be the exact same thing for number 6. I'd look first to see, are they already cubes? Can I jump right into this step? Or do they have something in common that I can pull out and work it that way? And then the last thing we did with our factoring was one of our old favorites, either guess and check or slide and divide. Now again, if you're a guess and checker, keep guess and checking. If you're not, reminder. If we're going to slide and divide to make this a little bit easier, I slide my lead coefficient down to the end. Again, when I slide it, it's multiplying. So this is going to turn into a diamond problem. So I look to see where my clues are at. I'm like, okay, my multiply number is positive. Means my signs are going to be the same. My middle term will tell me what the sign is. So minus, minus. So here's what that tells me. I need two numbers that multiply to 105 that are going to add up to 26. Now, that may not be something you know off the top of your head. So maybe you start playing with some numbers. 3 and 35, they don't add up to 26. 4 doesn't go in. Okay, 5 is 5 and 21. Does that add up to 26? Yeah. So sometimes it just takes being a little patient with it. But again, you're not done. That number that we slid before, that we multiplied down, we need to divide by it. So if I try to reduce it and it goes in nice, 21 divided by 3 is 7. Super. Be good there. If it doesn't go in nice, I punch in 5 divided by 3 in my calculator and I get a decimal. That coefficient is going to slide back to the front. And I'm good. And I'm going to do the exact same thing on number 8. Okay, so again, it kind of gives you one to be able to practice with as well. Okay, so that takes us back to the start of what we were doing since our last quiz. Now we start moving more into what we've been doing here recently. Find the inverse. Okay, reminder, two-step process. Switch x and y. Solve for y. And I might have to even remind myself, oh yeah, f of x is just a fancy way of saying y equals. And if you do happen to get a problem that doesn't have an x here, it has like an n or an h or something, you can turn it into x if you want to. That's fine. So, okay, I'm looking at this and I'm going, okay, first job. We're going to switch x and y. And I mean that literally. Okay, they switch spots. Now my job is to get y by itself. So I'm like, okay, so my first job, if I'm trying to get y by itself, I see two things are going on here. I'm dividing by 9 and I'm minusing 2. What one do I do first? Typically, if it's a multiply or divide issue, we're going to deal with that first. So in this case, I'm going to multiply both sides by 9, because that's the opposite of dividing. One thing to watch out for, it doesn't mean I distribute the 9 through, because all that 9 is going to do is cancel this out. And say bye-bye fraction. Once I have this, now life should be easier. I want to get y by itself. I'm minusing 2. I do the opposite. And then my last step, going along with what we do when we've been graphing these, is to divide all of my terms by 5. And if something reduces down nice, that's great. And if it doesn't reduce down nice, that's okay too. Fractions aren't a bad thing. And even if you left it as 9x plus 2 over 5, that is the same thing. That would be a good answer. So switch x and y, solve for y on our inverse. Now then we get into the stuff we didn't have a real good time with at times. So we're going to chat on both of these. So state if the given functions are inverses. Does f of g of x equal x And g of f of x equal x. Now we're gonna even simplify this a little bit more, because we found this maybe worked a little bit better when we were doing day 2 of this stuff. So okay, first job. I'm going to take my second one, so I'm going to plug f into h. So this is what I'm actually doing. I'm doing h of f of x. That's what that means. So what I'm saying is I'm going to take this and I'm going to plug it into where the x is. So here's what that looks like. So 4, when I get to x, I replace that. Okay, so all I did was x went out, this stuff went in, and now I'm going to simplify it. So I distribute. 4 times negative 4 is negative 16. 4 times 1/4 is 1. I could do that on the calculator if I needed to. And if I have like terms, and I do in this case, 16 minus 16 cancels and leaves me with x, and that's what I want to happen. So I passed step 1. Now, if I'd have done all this and I got any other answer besides x, 4x plus 3, 15, something like that, it's no, and I'm done. But since I passed the first part, I need to do the second part now. So the second part is to switch the order. So we're going to plug h into f, which is f of h of x. So basically, I'm going to flip what I just did. I'm going to take this, and I'm going to plug it in for x in this one. So I start copying all my stuff in my f function until I get to x. When I get here, this stuff goes in for that x. Okay, so that x disappears and gets replaced. And again, sometimes even seeing the colors with what you're replacing can help. So I still got some reds and blues up here, if that helps you. And we're going to distribute. 1/4 of 4 is 1. 1/4 of 16 is 4. Combine my like terms. I get x. And since they both are x, yes, those would be inverses of each other. Okay, it has to be both for the answer to be yes. And you cannot just write on the quiz tomorrow, take a 50-50 shot and write yes or no with no work and think you're going to be okay. Not quite going to work. So if I do that again on 12, so my first job would be to go g is going into f. So I'm going to take this, I'm going to plug it right in there. So let's see if this one works. So I start copying my f function until I get to the x. Okay. So this is my f function with x replaced with the 5x minus 20. And just like I did on the first one, I'm going to do my simplifying and see where it takes me. So 3 times 5 is 15. 3 times negative 20 is negative 60. Combine like terms. And this does not look good. That is not just x. That's a whole lot of other stuff. I don't even have to do the other one. Once my first one gets me an answer that's not x, finished. Actually, it doesn't matter which order you do them in. Good question. The question was, well, what if I did it the other way? What if I did f into g first and then the other? As long as you do both, if one works, you're A-okay doing them in either order. Because I think in this case, I still would have ended up with the same answer after one of them. But yep, we always want to check both ways. Something to consider. And you've had some homework problems there too. So if that's a place you struggled, make sure you do those homework problems and check them out. Find the inverse of the function, then graph the function and its inverse. Okay, we're going to do one of these. I'm going to turn this into y equals again. So it says find the inverse. Okay, so first job. Switch x and y. Solve for y. So my job, get 6y alone. How do I do that? Do the opposite of what's being done to it, which is plus 3. So we're going to minus 3 first. Some of you may have noticed I stuck a 1 in front of my x. You'll see why I did that here in just a second. And so then my last job to get y alone, since I'm multiplying it by 6, is to divide everything by 6. So that's why I put the 1 in there. So it's going to be easier when I go to graph. And then 3 over 6, okay, is 1/2. So there's my inverse. And then it asks me to graph the function and its inverse. So I'm going to graph both of these. Now, if you're only working with one color, I don't even care if they're both the same color, the same line. I'm going to use different colors here. So 6x plus 3 means my y-intercept is at 3. First dot somewhere on the y-axis. And then my slope is 6 over 1. Now, if that takes me off the chart, I can kind of eyeball it here a bit. 1, 2, 3, 4, 5, 6, 1. That gets me pretty close. But if I want to put more dots, and having more than 2 dots is a good idea, since I went up and right, I can also do the opposite of both. So I could go down 1, 2, 3, 4, 5, 6, and left 1. I guess I could do 1, 2, 3. Try and make that a little bit better. And I'm going to do my best to find something that's a straight edge. Some of you, it could actually be a useful use of your phone. Get that in there. Now, some of you, when you get here, are going to be like, I'm not too sure if I like this 1/2 thing, because it's like I'm not sure where those values are going to go. So here's where my options are going to come into play. If I want some help, and I even could do this on the first one if I'm not real comfortable with graphing lines. I'm going to type this into the y equals part of the calculator. And I'll show you how you could do it without too. But just make sure when you're dealing with fractions that you're using parentheses, because otherwise the calculator gets a little confused. Bless you. So what I would do then is I'd do second graph to pull up my chart. And basically what I'm going to do is I'm going to go looking for where the whole numbers are at. So like -3, -1. Put a dot. 3, 0. Put a dot. And I mean, I could do some other ones in there too. 9, 1's kind of off my chart here. And what I do is I start to see the symmetry, because we talked about how these reflect over the line y equals x. Now, do you have to put the y equals x line in? No. I'm just doing it so you can visually see that these are mirror images over each other, and that's what my graph should look like. Okay, I should see those mirror images. Otherwise, if you were just going to graph, you'd plot a point at -1/2, and you'd go up 1 and over 1, 2, 3, 4, 5, 6. And you would keep doing it that way. So you've got options. And again, I'm going to leave 14 to you because it's a pretty simple inverse, and you getting some graphing practice is good. Okay, you've still got a key at the front if you want to check that to see if things are going okay. All right, let's see what else we got here. Divide using long division. Oh dear. Okay. Long division. X minus 1, 8x cubed minus 3x squared minus 2x plus 6. Okay. Grade school old, long division. 2 steps. First term divided by first term. First inside divided by first outside. 8x squared, because I subtract my exponents. Okay, my answer from number 1 gets put on top of my little division box. And then my second step is going to be to take that answer and multiply it times my divisor. 8x cubed minus 8x squared. And that value gets tucked underneath here and subtracted, just like when you do old school long division. And as long as your first terms are canceling each other, we're doing things well. If they don't, something didn't go right. -3 minus -8, or -3 plus 8, would be a positive 5x squared, and I pull my other stuff down. And I start the process over. First term divided by first term. Positive 5x. Take that 5x, distribute it to the x minus 1. And yes, to put some of you at ease, there will only be one of these on the quiz tomorrow. 5x squared minus 5x. It's not that this is like terrible, it's just, it's repetitive, and I've got to just watch out and make sure I'm watching out for the details. -2 minus -5, -2 plus 5. And I'm like, dang, there's still an x. I got to do it one last time. First term divided by first term. X's cancel. 3. Distribute it. And finally, on this step, when I subtract, okay, I'm still getting rid of my first, that's good. 6 minus -3, 6 plus 3 is 9, but I can't divide x into 9, there's no x's left. So now what? That's my remainder. So I put 9 over my divisor. No, you cannot just put R9. Okay, can't ignore it. If it was 0, I wouldn't have to worry about it, but since there is, I've got to leave it that way. Okay, so I'm going to leave you one of those to practice. Now, synthetic division, much friendlier, much more user-friendly, because these are the ones where I'm going to take the opposite of what I'm dividing by there, so -9, and then I'm just going to take the coefficients of my terms. Be careful. Remember, we don't want a degree gap in here. Wherever it starts, it should go down one step at a time. 3, 2, 1, 0. If there's a gap, I got to put a 0 in there to hold the place. But there isn't this time, so I'm just going to write the values down. And then, just like with the long division, we have a pattern. My first term gets pulled down. I take that number, I multiply it by what's in the box, put that into the next open slot, and add down. Okay, we're not subtracting on synthetic, we're adding. So that's a positive 10. Multiply, add down. Multiply, add down. And I put the signs in there with too, because in a moment when we put the variables back in, it's going to make that a little bit easier to deal with. So how do I put the variables back in? Go look at what degree you started with. We started with 3. We're going to start one less. So 2, 1, 0. And if there's still a number after that, that's my remainder. And we're ready to roll. And then the last part is kind of a review. We're going back to our operations with functions, where I have to pay attention to what exactly, and I'm trying to peek at what I got going here. Okay. What function am I being asked to do? Okay. Most of you, when you got stuck on the last quiz, mainly it was an issue of you got mixed up on what you were being asked to do. For instance, on 19 and 20, those are different things you're being asked to do. On 19, we're being told to multiply. Okay, this is telling me I want to do F times G. In other words, I want to do F times G. I can FOIL that out. I can box that out. Whichever I am better with. For a lot of you, the whole organization thing is a help, so I kind of push towards doing this with a box instead of foiling. And so again, when we're filling the box, we're multiplying, which means what? I multiply the coefficients, and I add the exponents. Multiply the coefficients. I don't have any other exponent. Multiply the coefficients. Multiply the coefficients. And then I just put my like terms together. And I'm good. Okay? So if it's a basic operation, plus, minus, multiply, just do that with the terms and be done. If it's the open circle, though, that's a composition. Okay? This is the one where I'm plugging one into the other. In other words, here, I'm plugging G into F, and it matters the order that I do it in. I can't plug F into G here. That's different. You're always plugging the second one back into the first one. So here's what that would look like. Here's my F function. When I get to the X, I'm replacing it with G. Everything else in my F function is normal, except the X is being replaced, and then I simplify what I have. Combine my terms that are alike, and I'm done. So what you're going to notice when we flip to the back here in a minute is sometimes it's going to be X, where I'm just combining stuff until I don't have any like terms left, and I'm done. There's going to be other times, okay, as we flip over, like for instance on 22, I'm not going to go into detail on 22 because I want to do a couple of the number ones here before we run out of time. But here, it's just combining like terms. It's this plus this. Put the stuff together to like I'm done. Okay, keep it simple. Well, what if I start putting numbers in there? Okay, so what's this mean? This means I'm going to take h of 2, and I'm going to subtract g of 2. So, I'm going to take my h function, I'm going to start writing it. But when I get to t, I'm going to replace it with the number. And then I figure out what that part is. 3 times 2 is 6, minus 3 is 3. Then I move over to g. Here's my g function. I'm going to replace the t with the value. T goes out, 2 goes in. 2 cubed is 8, plus 5 is 13. And now just do the math problem that's left. 3 minus 13 is negative 10. So when there's a number in the parentheses, I'm actually going to do the problem. Okay, I'm actually going to solve that. And then the last one that we're going to take a peek at, because again, 14 is the same idea, except we're going to add. when we get, let's say, to 25, you're like, oh dear, composition, and it's a number. So what does this mean? Okay, let's rewrite it this way, and then we'll kind of put it into English. G of h of 2. Okay, 2 steps. First step, we're going to find h of 2. In other words, we're going to plug 2 into the h function and get an answer. So here's my h. So 3, I get to the variable, I replace it with the number. Maybe I decide I'm going to put this into my calculator to make sure I don't mess this up. Because anyway, I'd have to remember exponents before multiply. Don't get sloppy. Okay, I get that answer. So now what? Well, now I know what this is. So my last part is going to be to find my g function at that answer. So I got to do the first step before I can do this. I'm working my way inside out. So there's my g. I replace the t with 9. Copy the rest. And get my answer. Okay, so the numbers play a little bit differently than the letters do. But you've had a lot of practice with this if you've done it. If you haven't, maybe you use this as your guide to go back, practice a few more of those, so you're feeling comfortable with this when it gets to be time for the quiz tomorrow. But again, the quiz itself is going to be 19 questions, so it's condensed from this. More likely just a couple of each of these instead of like a bajillion. But you've got to be ready or you will have a time crunch. So practice, practice, practice. If you need to, ask a few more questions. I'm here during advisory. I'm here after. I'm here tomorrow morning. So no excuses. Get it done. Be ready to roll. Thank you very much.